This video is about introduction to sequence as a function, part 3. Now, this particular question, we were asked to find a formula in terms of n for the nth term in each of the following sequence. Now, we have the first sequence is 2, 4, 6, 8. The next one is -7, -4, -1, 2. The next one is 1, 4, 9, 16. The other one is 1, 2, 4, 8, 16. And the E is 24, 12, 6, and 3. And the last one is 0, -1 over 2, -1, -1, 1 over 2. So let's begin. Now let's begin with the first one, the A part of the question. The A part of the question, you have 2, 4, 6, and what? 8. Now we are asked to find the nth term. Now we're going to first check the pattern. How, although I've known, I can tell you for free that I can tell you for free what is the nth term of this particular expression, this particular sequence. So, but let's solve it straight on. By looking at it, I can tell you what is it and the nth term. But let's do it for those that cannot look at the problem and be able to tell what should be the nth term. So now, first we're going to check the pattern, the way to be able to know how to start. Now we need to look at the numbers and be able to determine what is the pattern. So the pattern now, let's say this is the first term, this is the second term, this is the third term, and this is the fourth term. Now let's look at the common difference, which is the second term minus the first term. That will give us what? 4 minus 2. That is equal to 2. Now let's look at the third term minus the second term. This will give us what? 6 minus 4. This is 2. Now the fourth term minus the third term will give us what? 8 minus 6. This is 2. So it shows that it has a common difference, which is 2, 2, 2, 2. Now, since they have a common difference, and the common difference is equal to what? 2, the first term A is equal to 2, which is the same thing as T subscript 1. That is the first term. Now, since we have gotten this whole thing, we are going to use a general formula which says that Tn is equal to, this shows that this is an arithmetic progression. So there is a general formula for arithmetic progression, which is the nth term equal to A plus bracket open n minus 1 times the common difference. So now, applying that formula, you have, let me just clean this expression. So since we are not making use of this again, because we have gotten the first, the nth term. So now, because we have gotten the common difference, so the nth term now will not be the first term, which is A, is equal to 2 plus n minus 1 times, the dot is times what? 2, which is the common difference. So now let's open up this bracket. You have 2 plus this 2 times this n, give you 2n minus 2. So this will give us what? 2n. 2n. So the nth term for this is what? 2n. Let's go to the next problem. The next problem is B, the B part of the question, which is the sequence is -7, -4, -1, 2. Now let's look at the problem again. Look at this particular problem to know what is the pattern. Now let's look at whether it has a common difference. Now for us to check, we have the first term, the second term, the third term, and the fourth term. Now let's say the second term minus the first term, which will give us what? -4 minus -7. So this will give us what? 3. Now let's look at the third term minus the second term. You have -1 minus -4. So this will give us what? This is 3 too. Then the next one is the fourth term minus the third term. This will give us 2 minus -1, which is 3. So it has a common difference, which is what? 3. So the common difference is what? 3. And the first term A is what? Minus what? 7. Now, since we have gotten this, we can say this shows that this is an arithmetic progression. So since it's arithmetic progression, we use the generic formula for arithmetic progression, which is a plus bracket open n minus 1 times the common difference. So the first term is -7 plus n minus 1 times the common difference, which is 3. So we now have let's open up this bracket, -7 plus 3n minus 3. So this will give us 3n minus 10, because -7 minus 3 will give you -10. So the n term is equal to 3n minus 10. We can verify it now. Let's verify. The first term will now be, if you put the first term, meaning that is the nth term when n is equal to 1. So you have 3 times 1 minus 10. So this will give us -7. Let's look at the second term. This will be 3 times 2 minus 10. So this is 6 so it will give you -4. So you see, it's the same thing here. So there is no need to go verify further. Let's go to the C part of the question. The C part of the question is, now we are given 1, 4, 9, 16. Now let's look at it now. Let's see if it is an arithmetic progression first. But I've known by looking at it, I've been able to know what should be the solution to this particular problem. But I will just try to follow the pattern which we have been doing the other one, so that you will now notice something. So now let's look at the common difference. Now let's say here is still 1, the first term, the second term, the third term, and the fourth term. Now let's look for the common difference. Let's say the second term minus the first term will give you what? 4 minus 1. This is 3. The third term minus the second term is equal to 9 minus 4, which is what? 5. The fourth term minus the third term will give you what? 16 minus 9, which is what? This will give us what? 7. So if you check, you notice that there is a variation. There's no there is no common difference. So there is no common difference. You have 3, 5, 7. So there is no common difference. Now let's look at the pattern. Now we have 1, 4, 9, 16. So now let's look at another thing. If you look at here is 1 to the power 2. If this one is 2 to the power 2. This 9 is 3 to the power 2. And 16 is 4 to the power 2. So if you look at this properly, you see that this value is just you have 1, 2, 3, 4. So it has a period. It has now. If you look at the first term where n is equal to 1, here is 1. The second term where n is equal to 2, here is 2. The third term where n is equal to 3, here is 3. The fourth term where n is equal to 4, here is 4. So it now means that you can now see the pattern. Now, but this power here, the exponential is constant, which is 2. So it now implies that the nth term of this particular problem will now be the n to the power 2. So that is just the formula, the nth formula for this particular sequence. So now let's go to the next one. You have D, and D, you have 1, 2, 4, 8, 16. Now let's look at the pattern. You have 1. Now let's say here is the first term, the second term, the third term, the fourth term, and the fifth term. Now let's make use of. Now let's check if it is arithmetic progression. Now let's see if it has a common difference. Now you have the first one, the second term minus the first term, which is equal to 2 minus 1. This is 1. The next one is the third term minus the second term. This is equal to what? 4 minus 2, which is 2. We have the next one, which is the fourth term minus the third term, which is what? 8 minus 4. This is what? 4. We now have the next one, which is the fifth term minus the fourth term. This will give us what? 16 minus 8, which is what? 8. So you can see there is no common difference because the values are different. So it is not an arithmetic progression. Now let's look at what should it be. Let's look at the sequence to see what was the pattern the thing is giving us. Now we have 1, we have the other one 2, you have 2 to the power 2, the next one is 2 to the power what? 3, the next one was 2 to the power 4. So 16 is 2 to the power 4, 8 is 2 to the power 3. So there is a pattern. Then here 2 is the same thing as 2 to the power 1. So this one is 1 different from these other ones. And we know that anything raised to power 0 is what? 1. So that means this one is same thing as 2 raised to power 0. This is 2 raised to power 1. This is now 2 raised to power 3 and 2, sorry. This is 2 raised to power 3. This is 2 raised to power 4. Now we have, if you look at it, the first term you have 0. The second term you have 1. The third term you have 3. The fourth term, the fifth term you have 4. So we'll now look at it now. Now let's look at the powers. The powers, you have 0, 1, 2, 3, 4. So let's use the nth term of an arithmetic progression, which is a plus bracket open n minus 1 times t. Now, what we're looking at is the exponential in terms of n. So when looking at it, I know what it should be. But now let's do it. Now, the first term is a is 0. The first term a is 0, which is this. Then plus, when you look at it, the common difference is 1. So this is n minus 1 times what? 1. So this will give us what? N minus 1. So it now means that the exponential is n minus 1. But when you look at the base is the same, which is just 2, 2, 2. So it now implies that the n term, let me just clean this. We have gotten what we want here. We've gotten what we want there. So that means the nth term will now be equal to 2 to the power what? N minus 1. So this is the final answer for the D part of the problem. So now let's look at the E part of the problem. Now the E, we have 24, 12, 6, and what? 3. So this is the sequence. Now let's see if it is an arithmetic progression. Now here you have the first term, the second term, the third term, and the fourth term. Now let's see if it has a common difference. The second term minus the first term will give you what? 12 minus 24. This will give us minus 12. So this third term minus the second term will now be 6 minus 12. So this will give us minus 6. Now the fourth term minus the third term will give us what? 3 minus 6, which will be what? Minus 3. So this, look at it, there is no common difference. Now let's see if it is a geometric progression. Now we are going to look for the common ratio, whether it has a common ratio. So you say 2, the second term divided by the first term, which is what? 12 divided by 24. This will give us half. Now the third term divided by the second term, this will give us what? 6 divided by 12. This is what? Half 2. Now the fourth term divided by the third term, this will be 3 divided by 6. This is still half. So it shows that it has a common ratio. So since it has a common ratio, it's a geometric progression. So now let's work it out. Now let's look for, now since this is not arithmetic progression but rather a geometric progression, where here we have the common ratio as half. Now we're going to use the formula, the generic formula for geometric progression, which is a, the first term, times the common ratio raised to power n minus 1. So that is it. So now we're going to apply this formula. Now we have gotten the common ratio. The first term is equal to what? 24. So now let's apply this formula now. So the n term will now be 24 times r raised to power n minus 1. The r is what? Half. So let's just impute that. So have 24 times 1 all over 2 all raised to power n minus 1. So this will be equal to 2 Okay, 24 times 1 all over 2 raised to power n minus 1. So let's clean here now. Let's clean here. Oh yes, the n term will now be 24 divided by 2 to the power n minus 1. So, this can also be said to be 24 raised to power 2 to the power n times 2 to the power minus 1. Applying the law of indices. Now we have this 2 to the, like now the law of indices, if a raised to power n minus n is the same thing as a raised to power n times a raised to power minus n. So that is easy. So that is the same thing we just using here. And we also know that a raised to power minus n is the same thing as 1 all over a raised to power n. So that is what we're going to apply here. So we now have 24 divided by 2 to the power n times 1 all over 2. So it's the same thing with this. So anything raised to power 1 is that same thing. So now with the way these two come up here, you have 48 divided by 2 to the power n. So that is the nth term. So the nth term is what? 48 to the power 48 divided by 2 raised to power n, or we can say 48 times 2 raised to power minus n. Let me just put this times here. So that is the final answer for the E part of the question. So now let's look at the F part of the question, which is the final solution, the final problem. So now we have 0 minus 1 over 2, we have minus 1 minus 1 over 2. So now if you now say this, now this is the first term, the second term, third term, and the fourth term. Now let's look at this sequence to know the pattern, to know if it is an arithmetic progression. Now let's say the second term minus the first term will give you what? Minus half minus 0. This will give us minus half. Now if you say the third term minus the second term will be what? Will be minus 1 minus half. So this will give us what? Minus half. Now if you have the fourth term minus the third term, this will now be minus 1 over 2 minus 1. So this will give us half. So that means it has a common difference, which is minus half. So that means D is equal to minus 1 over 2. And the first term A is equal to what? 0. So now let's look at the nth term. So we're going to use the general formula for arithmetic progression, which is a plus bracket open n minus 1 times 1, the common difference. Now a is 0 plus n minus 1 times the common difference, which is minus half. So if we use minus half to multiply this, we now have 1 minus n times half, which is something as half over 1 minus n. So this is the final answer. This is the nth term. of this problem. Now, this is the end of this problem. Now, thank you for watching. Have a nice day. Please subscribe to my channel, hit the notification bell, and also do well to leave your comments in the comment section, and also like and share the video. Thank you.